Hello, welcome back here, guys. In the previous lecture, we have been talking about the stack. I was explaining on here on the main code how the variables, how the values from the variables, how they are added into the stack. In this lecture, we'll continue with a similar stuff. We'll be talking about the stack, and also I will introduce you heap memory. Okay, because we will be working both with a stack memory and also heap memory, and you should distinguish them because depending on the memory where the value is added to is behaving differently in the Rust. Okay, so let's start here. And actually, the first thing I will the picture here of the stack what I drew here, I will represent it in differently. I will be just talking not about the entire stack, but I will be talking about just about a single stack frame in the context of some values. Okay, so let me to open here new paper. Okay, so empty node landscape. So as I displayed before the stack frame from up to down, I will represent it linearly. Okay, so this will represent, let's say it will represent a single stack frame where the memory is laid out from the left to the right. So you have a different places where you're adding into the cells your values. Okay, so it will be simpler to understand it like this. And this will be like our stack frame. This will be our entire stack frame. So stack frame. Okay. So as we laid out before to our memory A, B, C, D, so we would have it like this. I will just simplify it. I will not mention here any address, anything. Let's say I will just write here. We added value 10, which is representing A. Then we added value 10, which is representing B. Right. Then we have added C, which is value 15. Okay, 15, and then we added D, which is value 20. Okay, so and now let's imagine. Well, let's imagine, but actually, I'll write it. We will be working with the strings. Okay, I'll create here a message string. Okay, and I'll write here hello. Okay, how this is added into the memory? This is actually not added onto the stack because on the stack you can only add values that are fixed size, that you know in advance how much size they will take. But you know how much size it will take A, B, C, D because they are that types is U32, so you know it will be taking 32 bits for bytes. This will take C will take I32, so again it will take 32 bits. This will take the 4 bytes. Okay, so you can place on stack only values with static size. So compiler can decide how much of space for a stack frame it can allocate. Okay, for numbers, for booleans, for these primitive types, it's very easy to say. So they are always added into the stack, and when you are copying one value into another, the new value is added onto the stack. Okay. That's how it works with the simple times, usually numbers, floats, booleans. They can be added like this on the stack. But with the message here, it's a little bit different. And by the way, this message is a type of AND-STR, okay? So with this is a little bit different. So when we add here a message, this will be actually added somewhere else. I will create this message. I will be talking about this string type later. This immutable string, you cannot update this string. I want to show you an example of this later. I will create a string differently. In Rust, you can create a strings also like this. String, you have accessible string here in a context. Column. That's when you want to access the function on the string. I will be also explaining this later, but this is not really important right now. But you can do it like this. String and a from. And you will write here some string. So as before, we had the hello here, right? So that will create also string, and you can normally print it out. Print a line, and you can normally, this will create a string. Okay, curly brackets here and the message. And when you output it, you can expect what you know what you will get there, right? So cargo run, you will get the message simply here hello. Okay, so we have talked about these predictable types, which are integer, floats, and booleans. They can be added easily on the stack, but there's a different story for the message, for a string. When something is a type of a string, it's not predictable because the hello can be just can have this length of the 5 characters, but it can be also updated to the length of unpredictable size. For example, if you're expecting the input from a user, from an application. The user can type only 5 characters, but it can write also 2 pages. So you don't know in advance how much space on the stack you need to assign. Okay, because a string can be 5 to million characters long, but you don't know, the compiler don't know this in advance. Actually doesn't know this in advance. The compiler doesn't know. It can deduce the type from the integer, floats, booleans, because that's only the number has a specific size. But for a strings, we don't know in advance how much size the string will take. So it's also behaving differently when it's added into the memory. Okay, so we will not store here hello like this. So okay, we will not store it hello like this here on the stack, because later the user can add hello world, and this will go all over the stack, and the stack frame will be not big enough to store these values. Okay, that would cause some problems. So the hello will be not stored like this. But what compiler knows is that we can store here some pointer that will point to the space in the memory where the hello will be stored, and it will be not stored in the stack memory, but it will be stored in the heap memory. Heap memory is more flexible, is dynamic, it can grow as you are allocating more values. Okay, so the value of this string here, hello, will be stored in the heap memory. What will be stored? There will be still some values put into the stack, but it will be just a pointer, will be pointing to the space in the heap where will be the string hello. So what we'll be storing here in the stack will be the 3 spaces for the string. Okay, so we'll be storing the 3 units of the spaces on the stack, and this will be our pointer to the hello. So this will be our hello pointer. Okay, but what we'll be storing will be pointer to the address, the specific address in the heap. So we'll call it pointer. Okay, pointer. Actually, this we can put here pointer. Then the capacity of the string, capacity, and the length of the string. The pointer will be some specific address, so this can be 0x or can be some number, so let's say 100. Okay, but yeah, to simplify, I don't want to specify here a specific address. Let's say the pointer will be just I'll be always writing here pointer. This is a pointer to some address in the heap. Okay, don't know now the specific address. Capacity will be how much space we have allocated in the heap. Let's say we have allocated for this 5 bytes. We've allocated capacity the heap for 5 bytes, and the actual length of the string for the hello is as well as 5 bytes. So we can allocate more space, but the length of the string can be lower. Okay, so the 5 bytes as well for a hello. And this will point to the space in the memory where actually hello will be stored. This will be stored somewhere in the heap memory where the hello will be stored. So we know how much pointer will take a space. For a pointer, we always need to allocate 1 space for the address, then 1 space for the capacity, then 1 space for the length. And these things we know in advance how much the size, because the capacity is just a number, so number can take up to 64 bytes, yes, and the length also until 64 bytes. So we always know to predict how much space we need to allocate for these dynamic values. But for a heap, how long it will take, the space, the string itself, we don't know. Okay, so here just need to store address, capacity, and the length, and the pointer will be pointing into the memory. All right, guys. So yeah, I think I will leave it here because there are some additional explanations I need to continue with this here. But just keep in mind, guys, simple values, integers, floats, booleans, so we know the size in advance, how many bytes they will take, we can store on the stack, no problem. The compiler can resolve this, the stack frame will be allocated, but for the strings values and also the other values we'll be talking later about, we don't know in advance. So that's why we are storing only pointer. And the pointer specific to the string here, pointer to the string is taking pointer itself on the stack, capacity, and the length. Pointer is pointing to the address in the heap where the actual value of the hello is stored. The capacity is how much memory we have allocated, because we can allocate more memory. Let's say if this would be capacity of 6, we would have here 1 more space allocated, which would be just empty. Okay, and the length is actual length of the string. And this size of the capacity length and the pointer are predictable, okay, because they are just the numbers. Alright guys, so that's gonna be it. I know, heap, stack, very complicated topics, but that's how we need to start with them. In the next lecture, I will show you some tricks, or actually some things you need to keep in mind when you're working with the strings, and also later I will be explaining the difference between this string type, which is at sign, at str, and between the capitalized string as we are using here. And don't worry about the syntax, also we'll be talking about this later. So guys, that's gonna be it. Cheers.